Okay, today's lesson, we are just adding one thing to what we've been doing, and that is actually showing what the pipes look like to find the clearance between pipes. So the layout is exactly the same as what we did last class period. We want to find the point view of one of the two lines. So to find the point view or the end view, I need to have the true length of one of the two lines. And it's entirely up to you which one you create the true length from. Since I've got plenty of room up here, I'm going to go this direction. As you can see, I was having a little bit of difficulty getting the parallel in there. Okay, so I'm going to find the true length of AB, and you're going to build this off of the center points. Because again, the lines that we've been using, we just kind of pretend those have been the center points of pipes. So now I will lay out my AB first of all. So that is going to be the true length of line AB. I'm going to label some points here real quick so I don't forget. And I'm also going to go ahead and label this as true length, just as a reminder. You don't have to do it on your plates, but I just don't want to get confused. And then I will do the same for C and D. Okay, and then once more, I'm just going to put a couple of quick labels on this one. All right, so now I've got my true length of line AB, so I need to find the end view of this line. So once more, I'm going to set up a hinge perpendicular to that line. And then once more, I'll set my ray from AB. My offset values for A and B will be identical, thus giving me a point view. So again, I want to make sure I label that point view as well. And then bring C and D across. Oops. And then of course I would label it, but I'll continue on in this case. So just like last class period, I wanted to find the shortest distance between two lines. I just simply need to draw a perpendicular to find that answer. Now in the last section, this would have been the answer. I could do an aligned dimension, and this was the clearance between the lines. But now you're being asked to find the clearance between two pipes. So what you will need to do is you'll need to actually figure out how big these pipes are. So I'm going to do an aligned dimension between this one to find out it has a diameter of 10, and this one has a diameter of 6. So I need to construct AB to look like it has a diameter of 6, so I'm going to use an offset value of 3 for the radius value and offset that center line each direction. And then I'm just going to go ahead and cap the ends with a line here. And then I'm going to offset the radial value of 5 for CD. That way it has a diameter of 10. And again, I'm just going to cap it with a line command. So then over in this view, this is CD. So once more, I'm going to offset that value of 5. And again, I'll go ahead and cap it. And then with the point view of AB, if I was looking at the end of this cylinder, I would see it as a circle. So I'm going to draw the circle with a radius of 3. And now I can see the actual pipes. Now I can calculate the clearance distance between them. So I'll just use an align dimension and pick up these couple of intersections between them and find out what the actual clearance is between the two pipes. So you don't want a dimension to the centers, you want a dimension to the pipes themselves. And then you also want to project back your intersections. So as I go back, it intersects with the center here. So you continue building it off of the centers. So it will go perpendicular to that center. And then I'll go ahead and project them back to the other views as well here. So this one intersected AB, so it will intersect AB here. So my perpendicular connector would look like this. And then finally I can draw rays straight down. And then AB is on the right, so my perpendicular connector would look like that in the front view. So you do need to show your perpendicular connector in each view. We're almost done with this one. The last thing that we need to do is to solve for the clearance of what the pipes look like. So the way that you do that is you begin with a ray in the view that you're trying to solve. So in this view, I'm trying to figure out, is pipe CD on top or is AB on top? So I'll start a ray at that intersection and go into the next view. And whichever one I run into first is the one that's on top in this view. And it should be the same thing both directions. So whichever direction I go, I run into the thinner pipe first, which is AB. So AB is on top in this view. So that means I am going to trim CD out of here. I'm going to leave the center lines in there for my connectors. But that way AB is on top. Nothing to solve for here. Down in the front view here, once more, I will start a ray at the intersection, go to the next view. What does it run into first? It runs into CD first, so that means CD is on top. So I will go ahead and trim out AB so that CD is on top. And that should make sense because if I'm looking this direction, I'll see CD first. So as I look at the front, I should see CD first. So let's look at the plates for today real quick. First of all, 10E. So you're going to do 10E, 10E2, and 10F. Very similar situation to what I just did, except these pipes have a little section appearance to them. You don't have to recreate that. As you're laying out the points, use the end points of the center lines. And then when you're drawing your pipes, you can just cap them off with square ends, just like I did in my example. So again, you need to find a true length. I don't have one. I'm going to have to create a true length, then find a point view, bring across all my diameters, and then solve for the visibility. And switch back here again. 10E2 is very similar, except in this one, PO is parallel to the horizontal plane, so PO is already true length, so you're ready to just skip straight to creating a point view or an end view of that line. And then you'll notice on these, this is because these plates were originally created for board drafting. The whole intersection is just not finished up, so you just want to finish it up. For example, if you decide PO is on top, and I'm not saying it is, but just as an example, you can just draw in the lines for PO as the pipe that is on top, and then you can use your extend command to extend the other pipe to meet. And again, I'm not saying for sure that PO is the one on top, just an example there. And then lastly is 10F. And this one, just like we did last class period, you're just going to create vertical connectors and perpendicular connectors and label them. So if you have any questions, I will try to be available via email. Otherwise, on Tuesday, we are still going to have our exam. What I'll do is I'll leave some time at the beginning to answer any questions since I'm not there today, and then you won't have to start the exam until you're finished with everything. So, thanks.